In this video, we'll draw the trend line and the polynomials of exponential decay and exponential saturation growth using Linus polynomial regression. First, we generate the decay, which is in the form of our formula, exponent of the x values, and there's a negative sign to it. So put in the negative sign and hit enter. Here we have the trend line polynomial of the decay function, which is to the degree of 6, and the trend line, it's decaying to 0. Next, we draw the trend line of the saturation, which is equal to our formula 1 minus the decay. So here we have the saturation and the trend line polynomial of the saturation growth. So we have the decay and the saturation growth. Next, we generate the Taylor series expansion of both the decay and the saturation growth, where it is the summation of a times x to the power k plus n. The value of k is data validation, list of items 0 and 1. 0 if it is decay, 1 if it is saturation. And the value of n is from 0 to infinity. So we start from 0, 1, 2, up to infinity. Well, 10 is good enough. So we now enter the Taylor series expansion. So RA formula, series sum of the x values. So that's a times x, where x is raised from to the power k plus n. So that is starting from k interval of 1, because our n value starts from 0, 1, 2, 3. So that's k interval. And the coefficients a will be this range. This is the coefficient. Next, we complete the coefficient, which is equal to RNA formula minus 1 to the power n divided by factorial k plus n. So k plus n. So now we can control our chart at k equals 0. That is decay. So the red line is on the blue data set. So that means our expansion, the Taylor series expansion, approximates the decay function. At k equals 1, the red line is on the green. That means the Taylor series expansion approximates the saturation growth. So next we calculate these regression coefficients of the polynomial using Linus. To do that, we'll use Linus, and we will complete the 1 comma x matrix starting with the power, which is equal to transpose from 0 to 6. Enter, because we have the polynomial to the 6th degree. Next, we complete the 1 comma x matrix. So RA formula of the x values raised to the power 0 to 6. Now that we have the 1 comma x matrix, we can now calculate Linus. So Linus, starting with the decay, data y, and data x. and the Taylor series expansion. So Linus, data y, and data x. And the the saturation growth. So Linus, data y, and data x. So let's compare the regression coefficients calculated against the polynomial. So we start with k equals 0. The trend line or the expansion is on the blue datasets. That means the Taylor series expansion approximates the decay and their trend line are the same, but the error increases as you go higher. But this is already negligible. At k equals 1, that is saturation. So the trend line, the red trend line is on the green dataset. The Taylor series expansion approximates the saturation growth. So their regression coefficients are the same, almost the same. And their polynomials are also, we have 0.99x, they're the same, 0.496x, almost the same, 0.16, and so on. This completes the use of Linus polynomial regression and Taylor series sum expansion to generate the comparison of exponential decay and exponential saturation growth.